Good afternoon, everyone. We are going to start this afternoon's presentation. Thank you for all being here at SAS Innovate. My name is Joy DeBolt from SAS, and I have the pleasure of introducing our speaker for today's session, Eduardo Joya. He will be presenting from our wonderful partner, Microsoft. So I will hand it over to you, Eduardo, and thank you for being here. Let's welcome him.
Nice to be here, and can you hear me? The usual test. All right, so we're going to cover the topic of that's very fashionable nowadays, which is agents. I'm going to emphasize more on autonomous agents because I believe that there's more of an interest nowadays on what's coming next. So where are we? We at Microsoft classify as Wave 3, which is what you have there. That's what I mean by Wave 3. Starting adoption of what we call autonomous or semi-autonomous agents, right? That's Wave 3, meaning companies are starting to explore that. So we're going to go into a little bit more of detail what we mean by a semi-autonomous agent. So where we are today, so yesterday, which feels like maybe a year ago or two, not that long ago, right? We had just a human team, us, biological creatures. Today, thanks to Copilot and the likes of it, you all must be familiar with Copilot. Is a term that we at Microsoft has coined to mean an AI that is a helper to your activities. So that's where we are now. We call it an AI augmented team. And the focus of today's presentation is going to be what we think will come next or is happening as we speak, therefore the Wave 3, which is you continue to leverage Copilot to help you as an individual or professional to be more successful. But in the background or in the foreground, you may have agents that operate as a support team for you. And the agents, they interact, they negotiate, they take actions based on policies that you define, right? So on that note, so Copilot is really meant for human augmentation, right? There's a Copilot for Office, there's a Copilot for Teams. And an agent, think of it as being an expert system that can work autonomously. You remember rules engines, expert systems from the past? Quite a few of those still around. So it's a probabilistic, think of it as a probabilistic expert system that is acting on behalf of you. And the complexity is when you have more than one and they interact. What do they do together? What procedures do they follow? Right? So a little bit of what is the use case for each one, right? So when you decide if you're going to go for Copilot or you're going to go for semi-autonomous agents, this is meant to help you think the process. So what's the business problem? Now, can I use a personal agent, like an Office or an Excel Copilot? Then your problem is solved. The individual can leverage the Copilot and to write an email, for example, or to do a summary of a document, right? It's a Word document. Now, maybe it's more complex than that. Maybe I need some help. There might already be an autonomous agent from a library that you can harvest and use, right? So some of those already come from the box from Microsoft. Others will come from our partners, right? But the agent already does that. Now, neither one exists. There's nothing I have. No partner has built it, or it's so specific to me that I want to build it myself. That's when you go to build your custom autonomous agent, and there's two ways to do that. One is going directly what we call pro code, right? Where you can use the Azure AI Agentic Service, right? Low code. This Copilot Studio is the example of the low code one, right? You don't need to know, a business person might be able to do it. Or you're going to do it coding yourself directly on AI Foundry. One example of a Copilot Studio which was built by Wells Fargo, right? It used Copilot Studio to build an agent, right? Which does help with research. Right? Research in financial institutions is a very time-consuming activity, You want to make sure that you can analyze and condense and summarize as many documents as possible. So this is one example, right? But this is an example of one agent performing a task on behalf of a human. Go and find everything there is to know about this particular stock or this particular company. Sentiment analysis, balance sheet, quarterly results, and summarize and bring it to me. That would be one example. So that's Copilot. That's one agent. And an agent has capabilities, attributes. So now we're going to get a little bit underneath of what an agent is. So think of an agent having the ability to process, interact with a human in a very unstructured manner, natural language, English, or it could be voice, could be even an image, right? That's what it means, natural language understanding, conversational interface. Now the Microsoft, when Copilot Studio or any of our AI offers, we provide it with what we call guardrails. A guardrail is, you must have heard it, responsible AI. Now we guarantee if you're using a large language model, let's say from OpenAI, through Azure OpenAI, we have protections in there to guarantee that there's no bias, that it doesn't have inappropriate behavior. It protects you from prompt injection. It's when a bad actor tries to hijack an AI agent to do something that's not supposed to do. So the guardrails came natively from Microsoft. We also provide connectors for data. So you don't need to do, you may need to do a connection to a data itself, but through Fabric, which is our product that does data abstraction for you, you can get connectors to many types of data, right? Fabric, for instance, is very much highlighted in our partnership with SAS. Comes with toolbox for developing if you want to augment it with Python code. It can be persistent. It can have a memory. It can be stateless or it can be stateful, right? So it can have a memory. It all depends on how you want to deploy it. But the specific knowledge, think of it, it comes without specific knowledge. So if you want to build an agent, in the case of Wells Fargo, they used all of this, but they built their specific, they designed and implemented their specific knowledge within that research agent, right? That comes from you. Microsoft, we are a platform company, right? We're not really industry specialized. So you get all of this as a starter set, and then you put intelligence into it, and that's where the specific knowledge comes from. And the reasoning here would be the large language model. It could be Llama, it could be Hugging Face, it could be Azure OpenAI. There's over 1,800 different models. The combination of all of this makes it an agent, right? But it starts to get complicated when you want to have more than one. Let's say you want to approve a loan, personal loan, right? So what would happen in this case? Well, we want to have multiple agents coordinating a complex decision. Each agent, and this is important, each agent is specialized in a certain part of the process to approve a loan, right? If you have one agent trying to do too many things, you run the risk of hallucination. So let's do a little play here. So this person, I call her Samantha. She wants a personal loan. She could go to a loan officer in a financial institution, or she could be interacting with an application. So the first challenge that you have is detect intent. What is it that Samantha wants? In this case, and we're building this for a retail bank. In this case, the orchestrator detects, she wants a loan. She's really interested in a loan, but it could be a loan. She could be calling for so many reasons, right? And you don't want to make good, do you want this, do you want that? You just want to, in the interaction, detect intent. The business orchestrator does that. Once it detects the intent she's interested in a personal loan, then which agent of the library of agents that I have has the skills to handle a loan? There's a loan agent, then it invokes that loan. It will be similar to invoking an API for approving a loan. Now it's invoking an agent. That agent has a recipe. It knows what needs to be done to approve a loan, right? And that recipe is, you have to do this, you have to do that, So the loan officer agent goes to the recipe for approving a loan and uses an orchestrator. And the orchestrator invokes a credit agent to do credit rate analysis, a compliance agent, and a login observability. This is not an entire loan process. I'm just trying to make a point here that the steps that would happen in a manual process using RPA, for example, or people actually moving document in a workflow from A to B to C to D, that process is now being superseded by this. Right? So what you have now is what usually is a back office function that's being implemented by multiple agents that know that it interact with each other, share memory, share data, and orchestrate the execution. And eventually, the outcome is a loan proposal that is being submitted for review by a human, which is the loan officer. So many things happening here. You had the loan officer agent that knows what are the steps needed in the process. So you don't have a prescriptive decision like an RPA would in the past, right? You have a compliance agent that using a policy document database to ensure that there is everything that is needed in the approval of a loan, in the review, submission, et cetera, is being done according to policy. And you have obviously login observability agent. So to a financial institution, it means now that every single transaction, this is hypothetical. We're still building this. I'm trying to give you guys a glimpse of what's coming, right? The third wave. So now, from a financial institution point of view, which is heavily regulated, you can guarantee that everything's done according to compliance. And you can guarantee that there's auditability and explainability through the login observability agent. You still want to have a person to review it, make sure everything's fine. We do not recommend this thing done entirely 100% without a human in the loop. But that's basically what the third wave is all about. Now, obviously, what's the challenge here? The challenge is building the agents. The challenge is orchestrating the agents in a dynamic way and not in a prescriptive, deterministic manner, right? Eventually, if the loan officer's happy with it, it will be exposed to Samantha, and then to her, it will look like people worked on this, and now she's happy, she has a loan approved, or she's unhappy if the loan was not approved, or whatever the caveats are. Now, what's happening in the background, right? In the background, the platform itself, all right, so this is a platform, I forgot to say this little detail. This is a multi-agent platform that Microsoft is releasing in build. So it's in a couple weeks, right? Right now, it's in private preview, but it has the attributes that you see here, right? It enables the development of agents at scale. So we go from Copilot, I want to build a Copilot agent, I want to use Copilot Studio to build one agent for me. You go from that to now I want to really build an ecosystem of agents that will perform back office functions or front office functions that in the past would have been automated via RPA and workflow. Right? So the platform brings out the, off the shelf, you have 1,800 or more agents. Right? You can connect them with endpoints outside of the company. So it's very open. The workflows are designed to be declarative. It's not if then else. It is recipe for approving a loan. First, check customer's identity. Second, check credit rating. Third, blah, 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 blah. And then what the orchestrator does, check identity. All right, I go to my agent directory. Which agent has the skills to check identity? Oh, this one, I'm gonna invoke it. And then it goes through that. So recipe is the recipes are created using a new language that we're launching at Build called within the platform, which is called FDL, Foundry Definition Language, right? So the agent does all the scaling necessary, all the allocation of resources. Building an agent within the platform is, like you said, you can use Python code, or you can use just plain English, or any language you want. And you are an agent that do this, do that. These are the documents you use for input. Very, very similar to what you have in Copilot Studio. The only difference is that now you can build many. And then it will build all the agents. It will build like a diagram, workflow. This agent talks to this agent. So you actually have a graphical representation of the flow of the process embedded in the platform, right? All right, so, and Now, if you think about what is it, and what is the right process that we took through. So you have an existing process, you model the current state, so you may or may not have the process properly documented. Sometimes you do, sometimes you don't. You model the future state, so I have an existing loan process, it's poorly documented, I want to change it, this is like business process reengineering done with agents, right? You want to redesign the process from scratch, you want to reevaluate the roles, participants, where do I need people, where don't I need people, right? Then you capture the benefits, time saved, cost takeout, compliance enhancements, and eventually you do all the change control necessary. But in the past, if you wanted to deploy a new process, design a new process, I'm talking about a process is a series of steps, human intervention, accessing an application, logging something, screen scraping, and all of that now is eligible to be optimized through an agent workflow. So what does it do well? In the past, we had legacy automating bots, which we all knew as RPA, right? So the problem with it, you have to build it, you have to maintain it, it's brittle, it's deterministic. What do you have with Agentic AI? Now you can build them in natural language, like we said before. It can perform complex tasks. In multi-agent deployments, you can use agents. You can have an agent execute a task, and remember the control agent I showed monitors it. So you have the agents monitoring agents. So what is it not good for? No, you don't want it to make decisions. So there are cases where you want to be not probabilistic but deterministic, right? If you're making a wire transfer, you don't want a probabilistic wire transfer, right? That would not work too well. So there are things that need to continue, use cases that to avoid, and if a decision is being made, generally speaking, that should always be reviewed by somebody who is an industry expert in that particular matter, right? Evaluate processes that augment decisioning systems, provide more information. The case of Wells Fargo is a typical case of augmenting a decision, right? It's easier and faster, I can get more and richer information for my particular research. Scenarios that support customer service activities like a contact center are very good for this as well. Now, another way to look at this approach is you have back office systems which are running, could be running mainframes, could be running distributed systems. I'm not proposing that those will be replaced. The systems, they're still there. What we're doing, we're creating an abstraction layer where autonomous, semi-autonomous agents will be the ones interfacing with the legacy systems or the back office systems that you have, right? So this is super important because you're not talking about wholesale replacement of an existing system. You're talking about letting that system be front-ended, manipulated, and used by an autonomous agent, right? This is the example of the retail bank I told you guys about. They wanna increase. They have a population of employees. It's about 100,000 employees, 98,000 to be more precise. They want to increase their customer-facing roles, right? And they're thinking, well, if I increase, I already spent a lot of money. Maybe I need to fire some people and reassign those roles. So they said basically they want to reassign 17,000 people to a customer-facing role. So the choice they had to make was, well, I'm going to have to reduce my headcount population somewhere and increase here. So what we proposed to them, even if you do that, even if you add 17,000 employees, on average, your customer-facing time will increase by 2 minutes, right? Because of the customer population. It's really, really worth it, and it can cost you anywhere from between 1 to 1.5 billion. These are actual bank between the redundancy costs of people, hiring costs of new folks, etc. People. The alternative here is keep your population as it is. Don't get rid of anybody. You have a lot of employees, a lot of culture. You don't want to really upset that. What you can do is work with us so that rather than 17,000 agents, we're going to create for you 1,000 product agents, right? And we're going to create also a digital representation of each one of your customers, which comes in the next slide. Basically, you augment the existing population to provide a better service to your customers without necessarily having to dismiss people. You improve the quality. We call that hyper-personalization. So in this particular case, let me give an example. In this particular case, 40% of the customers of this bank are low income, right? And they get a poor service, right? These are people who are not very financially literate. So even if they have some surplus money, what do you do with that? By creating a financial planner agent. Financial planners are expensive folks. They cost $200,000, $300,000 a year, right? Can't afford to put them on low income, but if we capture that knowledge and create a series of financial planner agents, we can advise folks, look, we noticed that, you have money parked here. Why don't you invest in, you can't run the risk, invest in a CD for 30 days, you're gonna make some money. So we start to provide a better service to a segment of the population that was mostly using direct deposit accounts and not doing much more. So for the bank, it's a win. They start to provide more of a personalized service without necessarily incurring a ton of cost or destroying their internal culture by firing people. This will take a longer to happen, but it's around the corner. What I showed you before, it's being built as we speak. What I'm showing now, it's not being built as we speak, but I firmly believe that as a CTO for FSI, I firmly believe it's coming, which I call it UL. Remember the Samantha, right? So Samantha today interacts directly with the bank for asking one thing or another. Tomorrow, what we want to build with this financial institution is a digital proxy for Samantha. So we know everything about her financials. If Samantha allows the bank to, she opts in, we'll have information about her social media, Instagram, what have you. So that little robot over there will be a digital proxy, a digital twin of Samantha, so that when you want to know whether or not Samantha would be interested in a lower interest rate mortgage, you don't need to bother her. If she would be interested in a new card, you don't need to bother her. Because the product, let's say the mortgage agent would interact, that's the idea, the mortgage agent will interact with the digital proxy for Samantha and knows whether or not a certain product, a certain offer is valuable for her. The reverse flow is also valid. Samantha can say, I want to refinance my home. I want to get some equity out of it because we want to remodel whatever. Well, I want to buy a car and I want to tap my equity in the house. Can you, Samantha proxy, go ahead, negotiate with the bank, see what you can do for me in terms of a low interest a second mortgage so I can get some equity out of the house. So it works both ways, right? We call this the CRM of the future because you go from your CRM that today is based on whatever people have, which is very sales-centric, to actually representing a moment in life of a person. So you really are, if Samantha is getting married or if she's pregnant, you will know she may need a bigger house. She may need a bigger car. And the bank or the financial institution is along the journey. This is called hyper-personalization, okay? Not yet, but around the corner. And another consequence of this approach is, our CEO, Satya, a few weeks ago or months ago said that, software as a service it's not going to be around anymore. What he really meant is, today we have catalogs, right? You go to the Microsoft marketplace and you'll see applications that you can instantiate, download, and consume, right? So those are applications. Tomorrow, what we see we're going to see autonomous agents that reside in a catalog. So SAS has a fraud prevention agent or fraud detection agent, right? That sits in a catalog that you can instantiate in your tenant, in your cloud, and consume, right? So what's the difference? The logic for fraud prevention, the data needed to consume, everything else comes preloaded with the agent. Right? So software as a service today, agents, ecosystems tomorrow. And you can have a catalog that is internal to your company, like the example I used on the bank, right? Where you have an agent for loan approvals, an agent for controlling loans according to policy, another agent for logging and visibility. That's an internal catalog. But you will also have external catalogs, like I guarantee you SAS is working on one, where you'll be able to tap an agent and bring it into your own instance. So this is what's around the corner. And now from a Microsoft point of view, we have I'm going to make an analogy: infrastructure as a service, platforms as a service, software as a service. You know, the more you're on software as a service, the stickier the platform is. But the closer you are to infrastructure as a service, the more you can code. So now Microsoft? So what do we have? Large language. This is AI Foundry, right? You know, you can use semantic kernel. LangChain is probably going to be replaced by semantic kernel, but you're coding. You're really down. You're calling the Azure OpenAI APIs directly. The other extreme that we have today is Copilot Studio Architecture. It's really meant for somebody not technical. It's meant for you, a business person, who's, hey, I want to create a Copilot Studio using natural language to filter my email or whatever. So that is for the end user. What we're announcing in Build is a platform where you can create and support multi-agents at scale. It's called Azure Agent Service, available in Build. And you can go and do it very simply using natural language, or you can actually code Python. So it connects the two extremes, right? But it's not really meant for a business person. It's meant more for the coder, for the IT function. And I believe that's all. So now questions, if you guys have any. Right?
So thank you so much for the presentation. It's pretty fascinating. One other question I have is that to have specialized agents, then you have to train on them. And where do you have those data from? And on the data provider, and is there any way to lower the cost to build specific agents? Because I find tuning is always a big cost, and is there any efforts in your end to make it easier? Or is it always gonna be like fine-tune, like prompt engineering, that's the lowest level and the low-cost version of tuning something? And the other question being that having multiple agents, if there's areas or overlapping, what if they give different answer? How do you solve that? It's kind of like a tree model in a way, that if different submodel give you contradicting result, then how you decide on that and whether there's weighting on that? Thanks so much.
Yeah, you're welcome. Is this thing working? You can hear me. So first question is specialized agents, who build them and where the data come from? So we are a platform provider, right? So what we do is we give you the models, and Hugging Face can be good for a certain use case. OpenAI might be good for another one. Llama may be good for a third one. Nowadays we even support Anthropic. So but we don't have the industry knowledge. So who will build, and you do not necessarily need to fine tune depending on the use case. So what we have is we have a platform. Now let's think of a company like Morningstar, right? They have all the data in the planet, or Moody's. What do? They get this platform, they have the data, right? And they have the industry knowledge. So they will be the ones that will be looking at this and say, oh, this is a neat platform that I have. They can be using Copilot Studio today, right? If they're just building one type of agent, specialize it. And they go in and say, well, I'm Morningstar. I want to create an agent that will provide information on mutual funds. They have hundreds of data sources. They have the industry knowledge. They will be the ones building that. We'll provide technical support, but ultimately it's to the data provider, Morningstar, Moody's, SAS, to decide what data is relevant, what's the use case, right? And whether I should use one model or another. What we try to provide is all the facilities to make the development easy, but Moody's knows about mutual funds much more than Microsoft. So they will make the decision. And it's not necessarily going to be fine-tuned. The decision will be what's the use case, what's the benefit, should it be just mutual funds, certain type, or should it be more broad? Those are entirely decisions that we cannot make. So your answer is the data provider needs to build it. Like we do the same with SaaS, right? We provide the platform and they decide. Now, fine-tune is not our only answer. You may or may not need. Sometimes you have a model that will provide what you need without fine-tuning because the data is there and the scope of the agents is narrow enough that you do not need to fine-tune. And the other comment on the cost and everything else, the cost is dropping down dramatically. You must have seen it, right? So it's becoming ridiculous. The amount of, ridiculous in a positive way, how quickly it's dropping. So I do not think the economics are going to be an issue anymore in the near term. Now your second question was about, what was the second question?
So it's about when there's overlapping.
Oh, yeah. So there will be an overlap. Now, you could get an agent that does research from Moody's, another one from Morningstar, right? And they compete. And obviously, this is a probabilistic model, right? So that you can get a different answer for the same input. But again, the provider of the agent, let's say Moody's versus Morningstar, they will have to calibrate and say this agent is good for this, as long as and let's say I'm a financial institution, let's say I'm a bank, and I have a research department, right? And I say, you know what, I don't want to build my own. I'm gonna bring one from Moody's and one from Morningstar, and I'm gonna use both, and then I come to the conclusion that I like one better than the other. And they may provide different answers because the data sources could be different, or the logic that they apply is also different because that's exactly what their intellectual property is, right? Data and the reasoning, correct? So you may say that Moody's is better for certain things, Morningstar is better for another one, then you want to keep both. So again, it's not deterministic. It's really meant to be, you're capturing the intelligence and the data from a ISV, from a software company, right? So that's that. Okay, anyone else?
We probably have time for one more.
One more question. Hopefully I can answer it. It's always debatable. You never know.
All right, I just had a question on, since we're looking at regulatory stuff, how is Microsoft looking at explainability and audit requirements in these agents that you're providing as a platform?
Yeah. Always a difficult question to answer. So let me start at the large language model. We have the responsible AI, which puts the guardrails in place. Then we have the second layer, additional guardrails that go and they say prevent prompt injection and detect data bias, etc. So we're trying to. This is also that every model has a bias, as long as it was part of the original design. It's desirable, right? It's desirable explainability as well as design. So now the models that we have explainability within the model. There's tools that provide you simulation that explain it, and so that's part of the tool set. In addition to that, what we recommend is that you also have a watchdog, which sounds weird, but you have an agent which is separate, whose job is to audit what your CRO would do, or your first level risk in a financial institution, or even a second level risk. So we're now in a situation. I mean, I tried to capture that in the diagram. Remember when I had the loan agent, and I had an agent which was taught. It uses a policy database, and its job is to guarantee that the loan agent, as it does the analysis and makes a recommendation or not, is doing that within the boundaries of the policy. So you have a checker agent, and that you're going to see more and more of that. And then you have the explainability and logic. So it actually in my opinion, becomes more granular than the process that financial institutions have, as long as, right, you have the guardrails in place and you have the control agent and the explainability agent. Right?
And
But it's more granular because I used to be the CTO of a bank, and then we had policies and everything else, but you have to audit, and you can't audit everything, right?
wonderful. And we actually have time for probably one more question.
It's
if
getting
anyone-
dangerous now.
I
I'm
know.
gonna get one I cannot
I
answer, I'm
know.
sure.
All right, one more.
Will these be able to run on like GCC High GovCloud?
Yes,
Hopefully that was an easy answer.
yeah.
Wonderful. Well, thank you all for joining the presentation today. Let's give a round of applause to our wonderful presenter.